All right, so here we go. All right, I'm going to move back to the first frame. First frame says, state whether the following combinations will make a buffer or not. So again, I've just got to give you constant practice at deciding whether something is a buffer. All right, so first speaker A, you've got HCN, weak acid. You have Na plus and Cn minus. It's a salt. It breaks apart. Who do I cross out, Hayden? Na. All right, so now I ask myself the question, Kyle, do HCN and Cn minus have a relationship? Yes. How do they differ? By 1H plus. Aha! They are a buffer together. Yay! I don't know whether it's acidic or basic because I don't have a K value, do I? But what if Ms. Matney told you that the Ka of HCN is about 6 times 10 to the minus 10? What would that tell you, Kyle, about the Kb, just the 10 part? 10 to the negative what? Oh, so Stephanie, if I have a Kb that's a negative 4 and a Ka that's a negative 10, who's better at dissociating, the base or the acid? The base. This would be a basic buffer. Agreed? So I'd have to give you a K value before you would know. All right, next one, and we're focused here on me. Matthew, put that away. Put that right now. All right, B is HClO, weak acid, and Li plus, and ClO2 minus, a basic anion. All right, so Matthew, who crosses out in my B? Okay, so Ashley, do this fellow and that fellow have a relationship? No. No, they don't differ by just one H. They differ by an H and they're not a buffer. They might be related somewhere down the line, but they're not kissing cousins. So the answer is no. All right, C, beaker has in it, oh, there is no C, sorry. D, beaker has in it K plus, C2H3O2 minus, and HC2H3 Jordan. Who crosses out? The K. And so then I ask myself the question, Ariel, do these two guys have a relationship? Yes, they do. How do they differ? By 1H. Therefore, they're a buffer. And if I happen to tell you that the Ka of acetic acid is 1.8 times 10 to the minus 5, Larissa, where would the Kb be just exponent-wise? -9. Good. All right. So, Janae? Would I have an acidic buffer or a basic buffer based upon the Ka versus the Kb? Basic, acidic. Acidic buffer because the Ka is bigger and a better dissociator thus, or the acid's a better dissociator because the K tells me more product than the other guy has. All right. So 2 more beakers, 3 more beakers, 2 more beakers. All right, E, we have Na plus, NO3 minus, that's a salt, so I separate them. I actually have a strong acid, so I separate it. Who do I get to spectate? Who does not cross out? Don't you ever cross out H plus or OH minus. Don't you do it. Because what that means is I have a neutral salt and a strong acid. Is that a buffer? Okay, y'all got duped on your exit ticket last class because a lot of y'all told me that that was a buffer because you thought it was. Because it sort of looks like it is. But if you've got somebody strong, strong things don't make buffers. Strong things don't make buffers. Did you hear me? Strong things do not make buffers. So this is a no. This is not a buffer. It is not a buffer. All right. So where's our F beaker? Our F beaker says we have H2SO4, which is going to be separated like this. And then we have Na2SO4, Na plus and SO4. Who do I cross out? Everything but the H. Thank you. Okay. So do I have a buffer? No, I don't have a buffer. No, I just have strong acid and a neutral salt. That's all I have. Strong acid and neutral salt. All right, last beaker is G, and I have Na plus and F minus, and I have HF. Matt, who crosses out? Na plus, and that leaves me with F minus and HF. Mariah, do they have a relationship? Yes. How do they differ? Huh? The H. All right, so is that a buffer? Yes. And what if I were to tell you, Kyle, that the Ka of HF is somewhere around 10 to the negative 4? What would the KB's negative be? Negative 10. So Kyle, acidic buffer or basic buffer? Acidic buffer. Do you see how that acidic buffer and basic buffer stuff works now? You just need a K value, one K value. You can figure out the other K value about, not completely, but that will tell you whether you have an acid component that's stronger or a base component that's stronger out of the two components, yes. You can make a nearly neutral buffer, yes, if the Ka and the Kb are almost the same. Yes, if both of them are negative 7, right, right. But is that a buffer? See, that's not a buffer, but that's a nearly neutral solution because their K's are the same values, but it's not a buffer. There's some buffers that are nearly neutral, maybe not 100% all the way to pH 7, but very close. Yes, there are some buffers out there, yes. So there's acidic buffers, basic buffers, and there's nearly neutral buffers as well, yes.
Are there any with
I would have to look at the K values, not any that are like real common. Yes, not any that are real common. All right, so my next little guy here is state whether the followings are acidic, basic, or neutral. Ready? Brianna. First one. What'd you say about that salt? You said he was totally neutral. Michael, what'd you say about that salt? CONO3 taken twice. He's acidic because that guy goes away. Both of those guys go away, right? All right, so Narik, what'd you say about this guy?
basic?
You said he was basic because strontium goes away and I'm left with the basic anion. Summer, what did you say about this one? This one's a little tricky.
I don't know.
Ira, what'd you say? You said basic. Matt, what'd you say?
I said neutral because I didn't want to deal with that.
I said it's
Okay, you said acidic. Matt, you said?
Acidic.
You said acidic. I'm going to go with acidic, and let me show you why. He breaks up into C2H5 taken twice. Now, here's the deal. I can understand. I'm with Matt. I understand where y'all are all at because I would be where Matt is. I don't want to deal with it because I really don't have a clue. Okay. All right. So here is what you have. When you break him up, you have this crazy looking cation, yes. It's organic, yes. Okay. And then you have this I minus. And it's not the I minus that's scaring you because you know that he gets kicked to the curb because he's neutral. But that C2H5 taken twice in H2 plus, he is the conjugate acid of C2H5 taken twice in H, which is called diethylamine. One of my big basics that I got to start recognizing. Yes. 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 All right. So when he sits in water, then let's just do this real quick. When this fellow sits in water, since he's an acid, what is he going to donate to the water? An H plus, making hydronium ion and C2H5 twice NH, his conjugate base. So that's why we call them conjugates of each other, because if I write it this way, he is actually not the conjugate. He's the weak acid, and this is the conjugate base. But technically, they are conjugates of each other. Yes? It's just if you're taking an AP exam and you have it written like this, and we read it from left to right, you always call this one the weak, and this side is his conjugate. Yes?
Is there a name for alkenes when they
Yeah. Diethyl ammonium ion. Because they have the exact same Lewis dot structure that ammonium, does. They look just like that. I just happen to have two H's, and on the other two spots, I happen to have a C2H5 and a C2. I know, I hit something. A C.
If you're on the cursor.
Thank you. C2H5. So that's why it's called diethyl ammonium ion. Yes. 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 All right, you with me? Okay, so last one. Last one, last one. Who have I not picked on yet? Who have I not picked on yet? Who have I picked on the rest? I haven't picked on you enough today. All right, K2SO3. What'd you say about him? You said neutral, and the K is definitely neutral. Is SO3 the same thing as SO4? No. Yes, because anions tend to be basic or neutral. There's only two exceptions to anions that are acidic. Yes? Okay, so you put this in water, pH higher than 7. You put this in water, pH lower than 7. You put this in water, pH higher than 7. Put this in water, pH lower than 7. Put this in water, pH is 7. And the proof is the dissociation equation, yes? Okay, so I would say at this point that I should be done.